In this video, we're going to look at how changing temperature now affects our change in equilibrium position. And the way to really think about this is first remember what it means to be exothermic and endothermic. So an exothermic reaction will release heat. Endothermic reaction absorbs heat. And the best way to determine how changing temperature will affect your equilibrium is to treat heat as either a product or a reactant. So exothermic reactions release heat, so heat is a product, and endothermic reactions absorb heat, so heat is a reactant. So let's take a look at how we can use this to our advantage. So exothermic reaction, heat is a product. So let's say we have N2 plus 3H2 goes to 2NH3 plus heat because it's exothermic. If we increase temperature, we add heat, and so our reaction will shift away from the heat and go to the left. So exothermic reactions, what you're doing is you're decreasing your concentration of products, you're increasing your concentration of reactants. Now K is products over reactants. You're decreasing your numerator, increasing your denominator, so K will decrease. So that is how temperature affects that system. Now, endothermic reaction. Endothermic reaction, heat is a reactant. So if you add heat, it's like you're adding a reactant, and so your reaction will shift to the right. So adding heat to an endothermic reaction, you remove the concentration, or you decrease the concentration of reactants, increase the concentration of products. KQ equals products over reactants. You increase the numerator, you decrease the denominator, so your K will get bigger. So let's talk about catalysts now. Let's just take a little sidestep here. Now, catalysts, what they do is that they speed up reactions by providing an alternative path. And catalysts, they both do the forward and reverse reaction. So they speed up the forward reaction, and they also speed up the reverse reaction. And they affect the forward and the forward and reverse reaction rates by the same amount. Therefore, catalysts don't actually change equilibrium. They affect the system equally everywhere. So equilibrium remains the same. Alright, so let's go back to the heat now, and let's look at an example problem. So if we have a reaction that is endothermic, carbon plus CO2 goes to carbon monoxide. So what will happen if we increase or decrease the reaction temperature, and how will the equilibrium constant change? So the way to go about this is, if it's endothermic, rewrite your equation with heat in there. Since it's endothermic, heat is a reactant, right? Now we write down our K expression. K equals CO squared divided by C times CO2. So if we add heat, it's like we're adding a reactant. We're going to shift to the product side. If we shift to the product side, we increase our numerator, decrease our denominator, K increases. If we remove temperature, it's like we are removing a reactant. Therefore, we will take some of our products and make them into reactants. Our numerator will decrease, our denominator will increase, and so we will decrease K. And that's it for this video. I'll see you in the next video.